Okay, let's just take a look at this electron transport chain and understand the process here of creating electrons and moving it towards the ATP synthase. First, we can notice that although there are 5 complexes, that only 3 of them are pumps. So complex 1, complex 3, and complex 4 are what we need to remember. So let's notice that NADH starts in complex 1 and NADH is converted to NAD+. However, FADH starts in complex 3, so it enters later in the chain, and this is why it only creates 2 ATP, whereas NADH will create 3 ATP. Sorry. Another thing to notice is the reason that the electrons move down is that as you move from the first complex down to the 4th complex till the end, that each complex is stealing the electrons from the other. It's stronger at binding the electrons, so that's why they move down. So why is FADH2 not generating as much energy as NADH? Remember, it's because it starts later in the chain. And the chain itself does not generate the electrons. What it does, it allows the hydrogen ions to be transported. What happens is, as NADH is converted to NAD, a conformational change happens, and so the hydrogen ions are able to be pumped across the membrane. Anyway, as we are generating a lot of electrons here, we're not actually making any ATP yet. This will happen when we get to the ATP synthase. And now let's look at complex 4. We can notice here water is produced after we have oxygen as the final electron acceptor. So what happens is that this is the final stage where the electrons are stolen, and that oxygen will accept these electrons and make water, and then we will move on to the final stage. One of the important things to notice here is that usually, for example, with ADP to ATP or the reverse, what's happening is that with phosphorylation you are activating, or you are creating a conformational chain, but here we're using electrons to enact that conformational change.